This video is going to be for Unit 4, Lesson 6 lab. It's Lab 27, the ionization constants of weak acids. And I will demonstrate it for you, and then you can actually do the calculations. So, first thing we have to do is here, this is a burette. We're going to do a titration. This is a burette, and we need to fill sodium hydroxide 0.1104 molar of sodium hydroxide into this burette. So I'm going to do that and fill it up. Come on. There we go. Okay, so we have sodium hydroxide in here. And let's open up the burette window. Oops, let's move it over here. Okay, the burette goes from 0 milliliters to 50 milliliters. And so when you let things drop in, not the water, but the sodium hydroxide drop in, you can keep track of exactly how much you're putting in a beaker down here. Okay, so we click on the beaker drawer, take out a clean beaker, and here we have the acid. This is a base, this is an acid. And so we're going to fill this up, the beaker up, with about half of this acid. Good enough. Okay, then we'll get a pipette. A pipette is an instrument used to very accurately measure different milliliters. And so this is going to measure out 10 milliliters of this acid. So here we'll fill up the bulb. And then we're going to take this beaker and just move it aside. We're going to take another beaker, clean beaker, put it under here, and empty this 10 milliliters of acid. Okay, this is the acid here. 10 milliliters of this acid into this beaker. So we'll empty that. And then we're going to put it under here. Now what we're going to do is we're going to add sodium hydroxide to the acid. Okay, an acid and a base, when it's an equal amount, it's neutralized. We're going to use indicators here. We're going to put the instruction says to use, here we have methyl violet, cresol red, thymol blue. We're going to use brom cresol green. Okay, so notice it turned yellow, and let's just here's the pH probe. Let's get the pH of that. Okay, so we haven't put anything in. Here's the acid. It has a pH of 2.87, so you should write that down. And it is yellow. Okay, so that answers number 4 on page 66. The color and pH of the solution. It is yellow, and it's 2.87. The pH is 2.87. And what we're going to do is drop sodium hydroxide in, 1 drop at a time, and you'll see this slowly going down until it changes color. When it changes color, we're going to note the pH, and that means the acid and the base are equal. So we'll just turn this on and let it go drop by drop. Notice how the pH is increasing as I put sodium hydroxide because it's neutralizing some of the acid. So it's not as acidic, it's going towards the base. And you really have to watch this careful. Okay, it's still yellow. As soon as it turns a color, I will click on it. And we'll notice the color, note the color and the pH. So there's still more acid in the beaker than base. Okay, it turned a green color. Notice it turned from yellow to green, and the pH is 3.82. So that's a second for number 6 on page 66. What are the color and pH of the solution? It is green, and the pH is about, let's see, well, before it was a 3. We'll say 3.83. Okay, so we need that information. It turns green, and it's 3. Well, going between 2 and 3. Okay, let's settle on 8.32. And then let's keep adding more. So now what's going on in here is that it's neutral. We have the same amount of OHs and hydroxide ions, OHs, and hydronium ions, H. Okay, equal amounts. Now if we keep adding this base, let's do a little faster. Notice how the pH is still increasing. And we'll see it turn a color. Still more base because it's getting bluer. Oops, there we go. Okay, so notice the pH is increasing because, whoops, now it turned blue. Okay, and this is a higher pH. Let's give it a minute to... Okay, we had 9, it's a higher pH. We really don't need that number, but we do have to note it turns blue. When we keep... So it's blue because we have more sodium hydroxide, the hydroxide ions here, than we do have hydrogen ions. So this is basic. So essentially that was the lab. You do have to do calculations from the data. If you look on page 67, it tells you, okay, it shows you when they're equal. And a pH is minus, and let's just write that up here. Okay, pH is equal to minus the log of the hydrogen ion concentration. Okay, so when it first turned green, when this turned green, the pH was about 3.8, what did we say, 3.83 is equal to minus the log of the hydrogen ion concentration. And so the lab asks you, what is this? You have to calculate this. Well, to calculate that, you need to do anti-logs. And so you would have to, at the back of the chemistry book, they have logs and anti-logs. And so you can calculate that. Okay, because when it first changed color, the pH was 3.83.